Fourth last one. Okay. I've done 19 this week. Okay, I got 4 more, and this is the fourth one. Fourth last one. Okay, let's go. Okay. Sorry. Sorry. Okay, let's go. Okay, of course, I'll still try to teach my best. Okay, so yeah, I won't compromise your learning from this. Okay, let's go. So for those seeing this for the very first time, which is I think the 6 of you, the 2 of you see 4 times already, so too bad. Okay, so yeah, this is the eMath session 2, okay, of the whole revision session series, and I think this is the very last one that we're doing online. So yeah, if you're here, welcome. Okay, who are we? So, oh my God, I said this how many times already today? Okay, so we are a group of tutors from OVERMUGGED. Okay, and yeah, I'm just going to say very quickly. Okay, we are a group of tutors from OVERMUGGED, and we are here to help you with your eMath. For me, I'm here to help you with your eMath. Okay, and yeah, help you get your A, hopefully. Okay, so the branches that we currently teach at is at Bukit Timah, Parkway Parade, and next. So the current location we are at right now is the Serangoon outlet. So for myself, I primarily focus myself in Parkway Parade and next. For Bukit Timah, I do teach JC classes there once, every single week. Okay. So we have other spaces as well that we use, Toa Payoh, Jurong East, and Woodlands, but this is not by us. This is owned by other people. So we usually use these spaces if there's a demand for students being in that area. So who am I? My name is Kaiwen, and I've been teaching for about 6 years already. And yeah, I teach math. I teach both O-levels and A-level mathematics. And I studied math in uni, okay, which is one of the weird people that do so, that everyone says has no future, but yes, I do. Okay, so yeah, I love math a lot, and this is really what I want to do for a living. I knew it from a very, very young age that I wanted to teach, and yeah, wanted to give back. So what are we doing today? We are doing everyone's favorite 2 topics on properties of circle and trigo. Okay, so just to check first, anyone here hasn't touched the trigo topic yet? Anyone haven't? Oh, not at all. A bit. Okay, so there are things I haven't learned yet. Okay, can. Anyone hasn't learned the circles topic yet? Or haven't? Okay, so if you haven't learned before, I wish you all the best. Okay, so you catch as much as you can. Honestly, catch as much as you can. Okay, no pressure. Okay, for trigo, same thing. You catch as much as you can. No, get out. Kidding. Sorry, my own students. Okay, so okay, see, faster. Okay. So you'll see more inside. All my stuff I put here. Like it. Okay, so yeah. Today we'll be going through the 2 topics, okay, which is the 2, I think one of the highly requested topics for eMath. Okay, and we'll be doing some questions today as well. So give me some time to run through the whole entire topic, and then we will be running through the questions together. Okay, so without further ado, let's begin. So in front of you, you should see 2 sets of notes. Oh, whoops. I already have already, right? So in front of you, you should see 2 sets of notes. One is with the spiral. Okay, both are spirals. One of them is session 1 and one of them is session 2. We are using the session 2 set of notes today. For the rest that never come before, you get the first one for free, okay, because you got too many. So this is our team that teaches math in OVERMUGGED. The fattest one is me. Okay, I teach math. I teach both O-level and A-level math. The skinnier guy in pink, he teaches JC math, and the girl, she teaches O-level math. Okay, just to check. Okay, practice questions. So for us, we prepared some questions for everyone, and these questions are here to supplement your school questions as well. So there are a few different things here. The monthly practice question series, this is from last year, the batch of questions that I gave my Sec 4s. So you can use them for your own revision if you want something to challenge you, something to demoralize you. Okay, if you want, what? And then for the curated practice questions, these are Sec 3 kind of questions, easier stuff, okay, that we have pulled out over the years, and we're going to use this. You're going to use this if you can use this, okay, for your own revision. Now just take note that the answers for the practice questions are already done. The monthly practice questions are done, curated, and this set of notes, the answers are not ready at the moment. End of this week, which I think is today, I mean next week. Okay, so next week or the week after. Okay, the answers will be out. Now, just to check, other than the two in front, anyone here that's Sec 4? Yeah, other than the two in front. But yes, no, okay, very good. Online, I don't really care. So, okay, so let's start, okay, with the topic here. For those that come to me for the very first time, okay, the practice questions are at the back. All these will be what we'll be covering later. You do not need to flip. Okay, for now, let's start off with the opening topic, which is on properties of circle. So to you that haven't learned before, you catch as much as you can. You're sitting beside your friend, right? Your friend is responsible in helping you. Okay, so if she doesn't do a good job, it is not my fault. Okay, so okay, for the rest, okay, we're gonna head into this first topic. So this first topic here is on properties of circle. Is this topic difficult? No, it's not. Okay, but if you have problems with this topic, then most likely I think it's because you don't have enough practice. So let's run through all the important stuff first. But I like to do this at the very start to scare people for fun. So for those that already know, then don't need. Okay, but for those that don't know yet, which is the remaining 6 people, okay, good that you hear this. I scared the Sec 2s just now. Very fun. So I'll scare you now too. What? Okay, I like the shocked faces from people. Very fun. No, I'm not sadistic. Okay, so I need to get my own fun out of this. Okay, your O-levels is next year, correct? Except for the two of you. Okay, for your O-levels are next year. We are all aiming for an A1, I assume. I assume, right? All aiming for A1, huh? Anyone aiming for anything else than that? A bit weird, huh? Okay, but it's okay. Aiming for A1. Now, okay, there are 2 papers, paper 1 and paper 2. Paper 1 is out of 90, and paper 2 is out of 90. You've heard me say this before, right? Okay, very good. The rest never heard before, right? Okay, very good. So, want to give a guess of the score that you need to score for paper 1 in order to get A1. Okay, the rest I know, but for those that don't know, just give me a guess. A very good number. 70, 75, too low. Higher, go higher. Try. Give a number. 80, too low. Behind. 85, too low. Beside. No. Okay, that one a bit unrealistic. No, not 90. Below that. Very good. Nice. 87. Okay, see, I like the faces. That's the face I'm looking for. I should put a camera here and then capture all the faces. Very fun. Okay, 87 is for paper 1. And then for paper 2, you want to give a guess? 85, very good, nice, good on the first try, 85, very good. Okay, so these are the average scores that you need to score an A1. I'm not kidding, okay? I will give you live statistics in a short while. Okay, so in paper 1, there's about 25 to 26 questions. So this means what? How many questions can you get wrong here? 1 out of 25. And for paper 2, there are about 10 to 11 questions. How many can you get wrong? Half. No, 1. Half a question in order to get A1. Now, I have real statistics to share. This one I don't think I shared with anyone, but I just share with you. 2 years ago, I got one student that scored paper 1 82, and paper 2 scored about 85, 84, 85. She got a B3. Okay, so yeah, that is a real thing. Okay, I'm sorry, but this is a fact of life. The reason is because of my favorite 3 English words. EMF is easy. Okay, so this is a fact lah. Okay, no choice. It's just like that. Okay, so let me help you. Okay, so we're gonna start with properties of circle. Now, for those that take Sec 3 now, do you take AMF? Okay, the majority should be taking AMF, right? Okay, just to share with you as well, this topic is coming back into AMF. Okay, so this topic plus your congruency and similarity is one of the last topics for your Sec 4 AMF region, and is one of the most difficult topics out there. So just be a bit careful. Okay, letting you know first because this is important. Okay, let's begin. So we're going to split the properties of circle into 2 sections: the symmetrical properties and then the angle properties. Let's start off first with the symmetrical properties. We start off with the chord theorem. Now notice at the start, every bulletin point, the solid bullet, okay, those are actually the names of the theorems that you need to give for exams. So for the first one, the chord theorem, it states that a chord is equidistant from the center to the chord. So this means that OE equals to OF. This is something that you need to know, okay, because sometimes it is tested once in a while. What is the definition of the chord? Now, a definition of a chord means is that it's a line that passes through the circle, enters one time, exits one time. This is the definition of a chord of a circle. This is something that you need to know. Okay, please remember the definition. Moving on, perpendicular bisectors. Now, for perpendicular bisectors, there are two properties here that you need to know. But before that, let's talk about the perpendicular bisector. What do you need to know about the perpendicular bisector? Please remember that bisectors and perpendicular, of course, cuts your line in half. Okay? It cuts every single line in half. So what does this mean? When you look at your theorem, the theorem states that a line segment drawn from the center to the midpoint, this will tell you why it cuts in half, and this will be perpendicular to the chord. Understand? So that's why it's called the perpendicular bisector theorem. Theorem number 2 is another version of this theorem. But first, to explain this, listen carefully. For a perpendicular bisector, I have 2 points. I label them as X. I'm going to connect these 2 points together like this, and I'm going to draw the perpendicular bisector. Now, this is one fact that you need to know. The distance from the vertices to the perpendicular bisectors are the same. So for example, if I dot to this point here, it is the same distance backwards. Same thing anywhere else, you're all the same. Understand? So this is the reason why for this particular theorem here, anywhere that you start along this perpendicular bisector will be equal distant to the 2 vertices. Understand? Okay, this is what we call the perpendicular bisector theorem. Moving on. Tangent theorem. Now, you need to know what is a tangent line. A tangent line is a line that cuts at one point. So, tangent, okay, is a point like that. This is a singular point. It will always be perpendicular to your radius. So the way that we write our reasons is tangent perpendicular to radius. Understand? One controversial question that we need to ask ourselves, is this symbol allowed for exams? What did your school say? Yes or no? You can just nod your head. Don't know. Yes. Don't know. Yes. No. Yes. Okay. It's controversial. That's why. In my opinion, the answer is no. You need to spell full. Okay, but there are certain places that allow you to spell in short form. Follow what your school says. Okay. Moving on. Now, another version of this formula is this. Okay. What happens when you're at an external point and then you draw 2 lines from this external point to the circle? And these 2 lines happen to be the tangent. The tangential at these 2 points. Now, we know that the length of these 2 lines to the tangential point are equal. Okay, these 2 lines are equal in length, and if you connect A and B together, this is an isosceles triangle. Understand? Now, I hope you know as well that these 2 triangles are congruent. What 2 triangles I'm talking about? OAT, OBT. So as a practice, can you do it now? Can you prove to me that these 2 triangles are congruent? Take 2 minutes, try. Okay, so I hope you have done it. Okay, let's look at the solution together. How do you prove that these two triangles are congruent? There are 4 different ways. Okay, I'll list out the 4 different steps that you need to prove it. I'm going to use RHS to prove the congruency. So, first one, let's talk about the hypotenuse. We know that OT is a common side. Next, the right angle. Angles OAT equals to angles OBT equals to 90. The reason is because tangent perpendicular to radius. Next one, this is your 90-degree, right? So this is your angle, R by angle. And then the S, you can choose whatever you want. OA equals to OB because of radii of the circle. The other possibility is that TA equals to TB, which is tangent from external point. And these are the 2 possible S's. And then by the SA, RHS or SSS or whatever congruency test, the triangles are congruent. Understand? Any questions before we move on? Okay, moving on to the next one, which are the angle properties. Everyone done copying? Sorry, before I move on. Oh, okay. Nice. Angle properties of circles. So there are 5 different properties here that you need to know. The first one, okay, is what we call angle at center equals 2 times angle at circumference. So every single property here has some conditions that you need to remember. Let's talk about them. I'll write down for every single property. So please take note. We start off with conditions. For the angle at center equals 2 times angle at circumference, what condition do you need to know? There must be 1 center and 3 points on the circumference. Okay, so 1 center and 3 points on the circumference. Now the property states that x is equals to 2y. So 3 points on the circumference will be 1, 2, and 3. Okay. Now, just to take note, there are 2 common mistakes here that some people will make whenever you are doing this particular property. Now, for those that haven't learned this topic before, okay, I'll be using 2 terms that you might not know yet. Later, then we relate them together. But for those that have already learned before, you should already know these terms. Common mistake number 1, the cyclic chord. This diagram here that I drew for you, is this a cyclic chord? No, it is not. Okay, this is not a cyclic chord. Why? What's the condition for a cyclic chord? All 4 corners must touch the circle, correct? So all 4 corners touch the circle. But for this case here, can you see that this is the center? This does not touch the circle. Okay, so please be very careful. This is not the cyclic chord property. This is actually angle at center equals 2 times angle at circumference. Another thing that you should take note of, notice here, this is a reflex angle. This is a reflex angle, not the inside one. That one is wrong. Okay, please be careful. Common mistakes. Number 2, this is another one, the butterfly. Okay, so for the butterfly, is this the butterfly shape? No. What's the condition for the butterfly? all four corners must touch the circle, correct? For this case here, you can clearly see this is a center. So this does not work. One more thing that you need to remember is this. This particular shape came out before for O-levels. If you want to take note of where, 2022, O-level, paper 1, question 17. But I know my stuff. And I've been doing this for very long. I did this 3 times already, and I did 1 in the morning. That's how I remember. Okay, so that's why. This particular question came out before, and trust me, many people make the mistake before. Okay, so this is not the butterfly, so be very, very careful. Okay, moving on. Angles in a semicircle. Now, for angles in a semicircle, now from the name itself, you should already know what is the condition for this to work. Condition. What's the condition? There must be a diameter. This line down here that I highlight, this is a diameter of the circle. A few things that you should be very careful about whenever you do these kind of questions. Can you assume that any random line is a diameter in the circle? Obviously not. What you need to be very careful about is that sometimes your lines may not be straight, or it might not even cut through the center of the circle. It must be stated within the question that it cuts through the center of the circle. Understand? Or you see cut the center of the circle and you know that the line is straight. Then okay, this is a diameter of the line, or diameter of the circle. Okay, please be very careful about this. Don't make that mistake. The last thing is this. This is a common question that some people ask. Okay, and many people have fallen into this trap before. Sometimes the line they give you is actually a diameter. But the last point here, is it necessary for it to be on the circle? Yes, it is. It is necessary, because if it's not, then the angle is different. For example, if I draw you a triangle that is like that, is that 90 degrees? No. So that's another condition. The last point must be on the circle. Understand? So please be very careful. Don't make mistakes like this. Like I said, 1 mark equals to your grade. Flying. Okay. Next, the butterfly. This is the butterfly property, okay, or what we call angles in the same segment. Please do not write butterfly in exams. Okay, you write angles in the same segment. I have seen someone did it before. Very unfortunately, I forgot to take a picture of that. Or else, yeah, I would have shown it. But yes, the student wrote it for prelims, and it was quite funny. Okay, so please do not, okay, the property should be angles in the same segment. I think got someone write before angles in the same butterfly also. Okay, or something strange like that. So please be careful. Okay, don't write something stupid. I rather you leave it blank than write it. Okay. Now, one thing I want to say is this: the angles that are equal. This is equals to this. Follow my highlights. This is equals to this. Now, question: can you tell that these two triangles here are congruent? Obvious, right? Because why? Why are they congruent? You can see that all the lengths are equal. OC, OD, OA, OB, all equal, right? And the angles are also equal by the property. So they are definitely congruent. Okay. One very interesting question that some people ask: is it necessary for the butterfly to cut the center? Okay, think about this first. Think about this. Is it necessary for the butterfly to cut the center of the circle? Yes or no? Okay, to my sec course, your O-levels is less than 50 days. Yes or no? No. The rest? I never say wrong, I never say correct. Yes, no, yes. Just curious. Yes. No. No. Yes. Never learned before, right? Okay, never mind. You really never learned before? Okay, okay. You, yes or no? No. No. Okay, the answer is no. It's not necessary. Okay, it is not necessary for you to cut the center. No one says you need to. Okay, it just so happens that this diagram I decide to draw it with the center. Understand? Moving on. Any questions? Oh yes, condition. What's the condition? I think it's all pretty obvious, right? All four corners must touch the circle. Okay, you might want to jot that down. Condition. All four touch the circle. Another very interesting question. Might as well just ask, right? Okay, another interesting question came out that time for another student. Okay, for example, you see the lines AD and BC? Must they be straight? It means this. Can it be like that? So for example, let's say if it's the intersection point is there, for example. 1, 2, 3, 4. Okay, wait. Make it a bit more exaggerated. 5, 6. Does this consider as the butterfly? Okay, think about it. Few seconds. Think about it. Okay, 1 round. No? Yes. Yes. No. It's half now so far. Yes. 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 Never done before. No. No. Okay. The answer is no. Okay, the answer is no. It's not considered as the butterfly. The butterfly in the lines need to be straight. Okay, so these are just common questions that people ask. So be careful. What? You sure not? Can get A now. Can get A now. Okay, moving on. Angle properties of a cyclic quadrilateral. Now, if you've never learned this before, okay, what is a cyclic quadrilateral? Now, a cyclic quadrilateral, just from the name itself, cyclic means circle. Quadrilateral means four-sided figure. It means a four-sided figure embedded within a circle. So what's the condition for something to be a cyclic quad? All four corners must touch the circle. Understand? So all 4 points touch the circle. There are 2 properties down here. Angles in opposite segment and the bottom one. The bottom one in a short while. So let's just take note of the angles. We pair up the opposite angles. BD, AC. These angles add up to 180 degrees. Okay. Moving on to the next property. Oh, yes, one thing. Someone asked me this just now in the morning. Very good. Very good question. Some schools teach students to write angles in a cyclic quad. Or some schools write angles in opposite angles in a cyclic quad. Yeah, something like that. Are these 2 allowed? Yes. Okay, you can write in whatever way you want. The important thing you must write that these are opposite segments. Okay. And the last one is this property here. Exterior angle equals to the sum of the exterior angle equals to the interior opposite angle. If you've never seen this before, it's okay. It's a bit more obscure, but the property states that the pink color angle here equals to this exterior pink color angle here. Now let's look at a very quick proof as to why this is true. We all know DAB plus BCD adds up to 180 degrees. Agree? So let's label this as Y. Agree, right? So we now know that X plus Y equals to 180 degrees. Let's assume DCE is a straight line. So do you agree with me that X plus Y also 180? So that's why they are equal. Understand? This is very similar to the triangle counterpart. There's a triangle version of this as well. It's also very obscure, but very powerful. This property, where if you take this angle and this angle, let's call this alpha and beta, and let's call this gamma. Alpha plus beta equals to gamma. And we call this property exterior angle equals to the sum of interior opposite angle. I'll spell the whole thing for you. Exterior angle equals to the sum of interior angle. Does anyone need an explanation as to why this is true? Don't need, I hope don't need. If need, then ask. Anyone needs explanation for this? I think it's pretty, yeah. Need, don't need. Anyone need? Anyone need? Don't need, Okay, very good. If cannot, think of it on your own. Okay, self-learning. And we're done. See? Easy. So is this topic easy? Yeah. Even she say easy. Okay? Even my own students say easy. So it should be easy enough. What? Okay, moving on. Trigo. Okay, everyone's favorite topic. So we're gonna go into the realm of the EMF trigo now. Okay, I understand there's a further trigo section, correct? Okay, this chapter consists of everything, so don't need to worry. Okay, it's both the normal trigo stuff and the further trigo, which is all the bearings lah and everything. Everything all tested. So for you never learned before, you just catch as much as you can. Okay. Let's start very, very quickly. Let's start with the first thing, which is your Tokaso concepts. So we all know Tokaso. Okay, if you do not know that, you shouldn't be in Sec 3 or Sec 4. Okay, you should be in Sec 2. Okay, so Tokaso basically means tangent opposite over adjacent, cosine, adjacent over hypotenuse, sine opposite over hypotenuse. This is something you should already know. Okay, don't need me to say. Moving on. Special angles. Okay, wait, before you continue, this page is not very important. Okay, this page is not very important. But if you take AMF, yes, important. Okay, if you take AMF, this is pretty important because you need to know the values of your special angle. For EMF, not very necessary, but good to know as well. Okay, if you want. Next, let's talk about the obtuse angle. Okay, this is important. This is the start of your next section in your further trigo. The formulas are as such written there. Sine theta equals to sine 180 minus theta. Cosine theta equals to minus cosine 180 minus theta. The tangent one is just additional. Okay, but the first two you definitely need to know. Now, I believe most schools will tell people to memorize. Am I right? Okay, what if there's an easier way to memorize this? There is. All take AMF, right? The majority of you take AMF, right? I don't care about them, but the majority of you take AMF, right? Okay, if you do, you know your ASTC concepts, right? From your triple topic. ASTC. Okay? Now, we know that these are obtuse angles. So what quadrant are we in? 2. Agree? We are in this quadrant. Okay? So what quadrant is this? This is the S quadrant. And this is why your sine is positive and your cosine and tangents are negative. And I believe everyone memorized ASTC already. All students.com. That's how I remember. What? Okay, but ASTC, that's how I remember. So S is your S quadrant. The rest are on negative. Okay? Moving on. Any questions before we move on? Okay. Nice. Bearings. We're going to talk about the few concepts here that I know a lot of people are very bad at this. Am I right? Okay, there are secrets to this that I don't know whether your schools will teach, but I teach. Okay, what is a bearing? A bearing always starts from a point. You draw a north, and it's the line when you rotate clockwise. Correct? So, there's a secret. All bearing questions are phrased in the same way. You can go and check your TYS, you can go check papers if you don't believe me. They are all phrased in the exact same way. Of something, from something. Understand? I repeat again now. All bearing questions are phrased in the same way. of something from something. So how do you do this question? Just remember these steps. We start from the from, point of origin. Just remember it this way. From. From the from, we draw a north line. So let's look at an example. We do it together. For example, if there's an A point here and a B point here, I tell you of B from A. So what do we do? From the from, we draw a north line. Okay. Step 2, connect A and B together. Just open now. Okay. Okay, I cough, you open, okay? Okay, open already? Okay, so A connect to B, after that, join. This is your angle. Understand? This is the easiest way to do it. Okay, so I repeat one more time. Of something from something, start from the from, draw a north line, connect the 2 points together, that's your angle. Understand? Simple. You just need to practice, and this will be very easy. Next thing, bearings must always be 3 digits. So means anything below 100 must be 0 something something. Okay, question from someone. If the angle is 3, what should the value be? 003. Very good. Bearings, 1 dp, 2 dp, 3 SF. Okay, too quiet, right? Okay. 1 dp, 2 dp, 3 SF. Okay, open. Okay, so value, bearing, I ask you. 1 dp, 3 S, 1 SF. Did someone say 1 SF? Oh, okay. What is it? Okay, answer please. 3 SF. Anyone? It's 1 dp. Okay, it's 1 dp. Understand? Please remember that all angle questions are always in 1 dp. Okay? There are 3, right, that we all remember. 1 dp, 2 dp, 3 SF. Do you know when to use what? Okay, very simple. 1 dp is always used for angles. 2 dp is used for what? Anyone else? Okay, not only that, one more. Time. One more. Very good. Money. Who said that? Oh, okay, I know. Okay, money. Very good. Okay, money is always in 2 dp, and then 3 SF is everything else. Very good, nice. Everything else. Okay, but there's an exception. There's one tiny exception. If the answers are exact, then what do you leave it in? Exact. Okay, no, not sure. Exact. Oh, the value says, sorry. I thought I read it as she said, sorry. Okay, so it's exact answers, you should definitely leave in exact form. Okay? You want scissors? I got. Okay, pause. People need to open food. Okay, we pause for a while. I think it's faster if I walk out, take a scissors and come back. Unless she have it. Cepat. There's a scissors there. Sorry, snack break. Hang on, sorry. Okay, we're done. Okay, let's move on. Okay, next. Things that you need to know about bearing questions. Now, for bearing questions, you need to remember about the orientation of the north line. So most of the time, the norths are pointing up. Most of the time. There are rare cases where the norths are pointing in other directions. So if it is, then you need to point it in the other direction as well. You make sure you follow. Another thing is this. Every north line that you draw, these norths are always what? Parallel. Okay, so one of the more famous properties that we always use, interior angle. Okay. Last one is same thing here, 3 digits. Anything under 100, you must definitely use 3 digits. Okay. Ouch. Moving on. Depression and elevation. Now, for depression and elevation, there are very easy ways to memorize this, but for legal reasons, I cannot say why. So for elevations, just remember that if you're elevating something, means you're making something better. So you're going up. For depression, you fill in the blank yourself. Therefore, it's pointing down. Understand? Okay. So just remember one very easy way to remember how I remember. Elevation, look at the bird in the sky. Depression, look at money on the floor. That's how I remember. Very, very relatable and very easy way to remember. Okay. Now another thing, for legal reasons, I also cannot do. So I'm going to do a small version of it. Watch carefully. For those online, I never on video, so too bad. Okay, so elevation means you like that, look up. This is the angle. Okay, I cannot extend my hand. You understand why? Okay, depression, like that, look down. Understand? But the important thing is your eye line. Okay, if you get the joke, then good. If you don't, then too bad. Okay, so remember, it's about the eye line. Okay, it's about the eye line. Okay? Okay? Now, another thing, if you're horrendous at this topic, if you're horrendous at this concept, just remember, bearing questions, depression questions, elevation questions are phrased in the same way. Of something, from something. And where do you start from? From. Understand? So that is where you draw your eyeball. Usually what I like to do is you draw your eyeball at the place where you're looking from, then you up or you down. Understand? So judging you right now. Okay, but never mind. Moving on. Area of a triangle. Okay, so for the area of a triangle, this is a formula that you need to know. Half AB sine C. Okay, remember, the angle C is the included angle in between A and B. Okay, it is in between the two sides. Sorry, there are a few things right now. Sorry, I'm being a bit crazy, but sorry. Okay, but C is the included angle in between the two sides. So this is your C. Okay. This is also given to you. Okay, you don't need to worry about memorizing. Shortest distance. Now, just a fun fact. Shortest distance questions and area or triangle questions, they always come together as a pair. It will always be one after the other. Okay, so what I like to say is this. Whenever you see an area of a triangle question, usually one part or two parts later, it will always be shortest distance. Why? Because of this formula. One of the methods to solving the shortest possible distance is to use this formula here. Half AB sine C equals to half times length times the height. Understand? It's always like that one. Okay. Now, one more thing that I forgot to mention, okay, apologies, is about greatest angle of elevation and greatest angle of depression. When you see the words greatest, it always means perpendicular. Understand? So there's a keyword. When you see the words greatest, it means perpendicular. So much no. Sorry for not mentioning. Okay. Now moving on. Another thing. Depression questions are always, depression and elevations always use the same ratio one. Tangent. Okay, it's always tangent because you're always given the height and you're always given the vertical or horizontal. Okay. Nice. Last one. Sine rule, cosine rule. Now for sine rule and cosine rule, these are given to you. Now, when do you use what? Very simple. The examples are given there. For sine rule, we usually use it for two angle, one side, two side, one angle. But please remember that the angle that we choose for two sides, one angle is always in between. Okay. For cosine rule, it is always three sides because of your ABC, or two sides, one included angle. There's another version of this formula as well, which is the cosine of C equals to A squared plus B squared minus C squared over 2AB. So this is another version that some people will use, also can. And last, two more secrets for you to use for exams. Cosine rule questions are always more expensive than the rest. Okay, there's a reason why. Because that formula requires more effort. Understand? It's usually the more expensive one. Usually, I say usually, because there are instances where it's not the case. Okay, do not take pictures, send me, say I'm wrong. No, usually, okay, usually 3 marks. If you want to spot 3 marks. Another thing, the way questions are designed for Trigo, they will test every single concept, like every single one. So what I like to do is this, just have a checklist in your head. You just remember, okay, I have area, sine rule, cosine rule, shortest distance, greatest angle, elevation. You list out all the 6 in your head, and then you start the question. If you hit something you cannot do, most likely it will be something you haven't used yet. It is very rare they will retest the same concept again. Understand? That's how questions are designed. Good questions, I mean. Okay. And we're done. Okay, so that is literally everything that I want to say for the whole topic. Okay, so I hope I've dumbed down the whole topic for you, okay, and made it easy to understand. Now it's your turn to shine, your turn to try. So we will start with 2 circle questions and 1 Trigo question. The 2 circle questions I want is question 1 and question 3. So I give you some time now. Please try. Does anyone need paper? Need foolscap or anything? Okay. For those online, same thing. You need foolscap, paper. For those that came for the very first time, anyone wants free A math note? The thick A4 book, the A4 size one. Anyone wants A math one? 1, 2, 3. Okay. You want? Anyone wants to release E math? Anyone wants to you want to see email? You want one? And second, algebra wants to go on this way. 1, 2, 3, 4. I'm good. Yeah, I think you need. Sorry, sorry. Hey. You know what? Can you please see anyone from the very long ones? Then what did you see? These two? One. I just say. Okay, let's go through at 5:15. Okay, let's go through. It's okay if you haven't finished. Okay, let's go through. Is the question very hard? Huh? Really? Very hard. Sec force. Can do? Okay, we check answer. Okay, wait. So we check answers first, okay, for those that have tried it. It is okay if you find this, for the sec 3s, it's okay if you find this hard. It is dangerous if for the sec 4s you find this difficult. Okay, so because this is a very simple question. So AOE answer is 50. Okay, we check answer first, then I go through everything. Part 2, answer is 70. Very good. Part 3, answer is, sorry, 110. Part 4, answer is 5. Part 5, answer is no, 50. Okay, those are the 5 answers. Okay, so let's quickly go through how to do. So this is a very standard question, and it tests literally every single possible concept. We start with AOE first. So where is AOE? So this is a very popular shape. Let's draw it out. 1, 2, 3. Nice. And what shape is this? Angle at center is 2 times angle at circumference. Okay. So the answer is 50. That's the reason why. So I'll write the solution for part A, part 1 over there. Okay, so I'll zoom in here and write. So let's say if you're not good at this topic, please follow the way I present my answers. This is very important. Okay. So for part 1, answer for this angles AOE equals to 50 degrees, or if you want to write 2 times 25 also can, okay, which is because angle at center is 2 times angle at circumference. So one thing I pride myself over like other tutors, and I tell people this, is that I'm good in my presentation. Okay, so I always like to present my answers to the best of his ability, and this is very important when you're doing math. Okay, so please follow the way that I present my answers. This should be the professional way that you do it, of course. Part 2, let's look at CBE. CBE. Okay, so I'm going to erase the highlighters here. So you might want to highlight on your own diagram. Okay, but I don't know how you can do because you need to highlight a lot. So CBE, this is definitely one of them. This is a diameter of the circle. BC, obviously, and CE. This is a right angle triangle. Okay, this is a right angle triangle. The reason is because BE is a diameter of the circle. Okay, so let's write the solution down. Now, you cannot just anyhow claim. You need to explain first. So let's say that BCE equals to 90 degrees. The reason is because angles in a semicircle. And then therefore, angles CBE equals to 180 degrees minus 90 minus 20. Final answer is 70 degrees. Now, this is one reason that many people will forget. Please listen carefully. Angles in a triangle. Now, you need to remember that if you're dealing with triangles, squares, quadrilaterals, or whatever, you need to give reason. Understand? Part 3. Angles CDE. Okay. Same thing I'm going to erase. Now, CDE is made up of this. So I'm going to highlight for you. BE, BC, CD, DE. And this is a cyclic quadrilateral. This is a 4-sided figure embedded within the circle. So this is a cyclic quadrilateral. So let's explain the answer. So for part 3, angles BDE is equals to 180 degrees minus 70. Answer is 110. Reason, angles in opposite segment. Okay, for those that are online, I'm going a bit fast. Okay, so if you can, please jot down as quickly as possible for all the answers. Okay. Part 4. OAC. Now, this one is maybe not the easiest one in the world. Okay, so let's go through very slowly. Please listen carefully. Now, for OAC, we are looking for this tiny angle down here. To find it, we first need to find CAE, which is this big one in here. How do you find that? And what is the value? The value is 70. Why? 2 reasons why. I can give you 2 reasons why this is 70. Number 1, the butterfly. There's a hidden butterfly within the question. Watch out. 1, 2, 3, 4. Butterfly. Okay. Reason number 2. Follow the one in blue. 1, 2, 3, 4. Cyclic quad. Understand? Both of them will give the same answer of 70 degrees. If you don't believe, please watch. This is 110 calculated from the previous part. We know that this is 70. Opposite angles of your cyclic chord will give you this as 70. Butterfly will also give you 70. Understand? Once you have worked out the 70 degrees, then what can we do? Okay, I'm going to erase my highlighters in a while. So everyone okay with this? Can you see it? Can I erase? Can I? Okay, I'm going to erase my highlighters away because I need to explain something. Now, the one that is the burden right now should be OAE, correct? Then you can take 70 minus the angle. Can you find OAE? Yes, very easily. How? This is 50 degrees. And what is so special about triangles OAE? Remember, center, OA, OE are radius. So this means that OA, OE, this is an isosceles triangle. So by calculations, you can work out that OAE is 65, and therefore, answer is 5. Understand the process? Let's write it down. Okay. So let's jot down the solution. Please follow how I write it. Angle CAE equals to 70 degrees. The reason is because angles in the same segment, or 180 minus 110 equals to 70, because angles in opposite segment. Either one, both will give the same answer. Step 2, angles OAE equals to 180 degrees minus 50 divided by 2 equals to 65. Reason, angles in an isosceles triangle. Can you see? You want me to shift more this way? Okay. Better. And then we are ready to compute our OAC, which is 70 degrees minus 65. Answer is 5. Do you need to give reasons for that last line? Obviously not. Why? There's no reason. Okay, but there's a certain list that you definitely need to give, like your triangles, 90 degrees, 180 at a point, all these standard stuff must give. But anything arbitrary or anything miscellaneous like this, we don't need to care. Understand? This is part 5. Part 4, sorry, part 4. Wait. B what? BAO. Tangents from external. BAO. Tangents from external point. Wait, Bravo Alpha origin. BAO, right? I hear it correctly, right? Huh? Wait, but the reason you give is tangents and external point. No, it should be isosceles triangle. Tangents and external point is you need to be outside the circle. You get what I mean? Yeah, I think the reason is wrong. Yeah, can. Sure. Okay, move on. Next is part 5. So for part 5, the answer is ATB, right? Okay, how do you find ATB? First thing, we work out this, which is 130. And we also know that OAT, OBT is 90 degrees. Why? Tangent perpendicular to radius. 360 minus that minus 90 will give the answer. Okay, so let's compute and write it down properly. Part 5. So angles AOB equals to 180 degrees minus 50, which is 130. This one need to give reason? Yes, because it's on the line. What's the reason? Angles on a straight line, or a faster one, supplementary angle. It means the same thing. You know your 90 degree one, there's another name for it, complementary angle. Okay, it's just a faster way. Okay, next, OAT equals to OBT equals to 90, which means tangent perpendicular to your radius, must state very clearly, and therefore ATB equals to 360 degrees minus 90 minus 90 minus 130. Final answer, 50 degrees. Need to give reason? Obviously. What's the reason? Angles in a quadrilateral. Okay, angles in a quadrilateral. Okay. And these are all the answers. Let's move into part B. Anyone got any problems? Part B. Okay, this is a very popular question. Explain why a circle may be drawn, pass through AOBT. Now, let's go through process of how to answer the question or how to get to the answer. If you need a circle to pass through 4 points, this means that these 4 points form a what? Cyclic chord. Agree? In order for you to cut the circle mark. So this forms a cyclic chord. Now, what's the condition to prove that this is a cyclic chord? Your opposite sides. Your opposite angles, I mean. So your opposite angles must sum to 180 degrees. So that's what we're going to prove. Let's prove it now. AOBT. Take this, 180, obviously. Okay? And we're done. And that's the whole question. So follow the way I write. Okay, I'm going to be a bit kiasu, so please follow. First one, angles AOB plus angles ATB equals to 50 plus 130 equals to 180. One thing you should take note is this thing I underline in red necessary. Yes, because this is a proof. You cannot just say something plus something equals to 180 and you expect us to figure out how you get the 180. Doesn't work that way. Okay. Next, because you're using a theorem to prove my statement, you need to state the theorem. You need to state the property. So you need to say by the property of angles in opposite segment. What does this imply to you? Now remember, be careful. This statement here implies to you that AOBT is a cyclic chord. It's not, this doesn't result in your 4 points touching the circle. No, it's because it's a cyclic chord. Therefore, it will touch the circle. Understand? There's a process you need to follow. Cannot jump the gun. Okay? So therefore, a circle will cut the a circle will cut the circle. A circle will cut the 4 points. Sure. Any questions? Okay, I have 2 questions to ask. 2 interesting things to ask. Number 1, okay, if you look at this whole entire solution that I did here, I did some things intentionally. I don't know whether you noticed that. Okay, but I did some stuff that I want to ask some questions about. Okay, number 1, notice that I drew like that. like that, like that, like that. Are these allowed? Okay, see, got different people shaking head and some people nodding. So are these allowed in exams? Okay, the answer is no, it's not. Okay, definitely not. Unless your school says so. If your school says so, follow up. Okay, the second one, this is the most controversial one. The angle symbol. This. Are these allowed? No, they're not. Okay, so this is also very controversial. Okay, a lot of people say no. A lot of people say yes. A lot of schools, they say yes. But from what I know, it's no. There's a reason why. If you don't trust me, you go flip your TYS. You open your TYS, you check every single angle question. They never ever use this symbol. They always spell full. There must be a reason why. Okay, so you follow your school. What I know also from my history of studying math, that symbol doesn't exist. It's just a placeholder that people use because people are lazy. Okay, one last one. Same thing, controversial question. You see, I purposely spell op like that. Do you notice? I think that's the only one. Okay? Is this allowed? No, this one definitely no. You must spell full. Okay, the reason why I did it like that is because I want to demonstrate a point up. And also another thing, because I'm teaching, I need to go fast. In exams, you need to go fast, but you're not teaching anyone. You need to present your answer to examiners. So you spell every single thing full. Understand? Okay, and this is the whole entire first question. Any questions? I might delay a little bit. Is that okay? I might extend just by a tiny bit because I want to finish the last question. I don't want to rush. So, okay. If you really need to go, then you let me know. I have another session after this, so to me, no difference. Okay, so, can? Now, moving on. Actually, I got one question I want to ask. Something interesting that I encountered a few days ago, but the other sessions I never share. Might as well just share here. Okay, I'll give you a simple question. You try, give me the answer. I have a circle. Wait, let me see if my idea works. Yeah, it works. Okay. I tell you that this is the center. This angle here is 100 degrees. For example. I tell you, okay, this is O, this is A, this is B. Okay, this is an interesting question. I tell you that there exists a point C that is somewhere here on this side of the circle, somewhere on this side of the circle, where the angle is equal to 50 degrees. Can I understand so far? Okay, the angle ACB will be 50. Okay. Does this point C lie on the circle, outside the circle, or inside the circle? Do you understand my question? I repeat again. This is a figure like this. There exists a point C somewhere in this region. Okay. I tell you that angle ACB is 50 degrees. Does the point C lie on the circle, outside the circle, or inside the circle? Okay, think about it. Then give me the answer. Inside, on, or outside? Okay, think. 30 seconds to think. We have done this before. It's a prelim question. Okay, so your 30 seconds is up. Inside, on, outside. Okay, I'll ask them last. Just guess. Don't know, guess. On. Inside. On the circumference. On. Just give a guess. Inside. Outside. outside. Sorry, on. Inside. Out. Outside. Okay. On. The answer is on. Okay. Why? Okay, look at the numbers carefully. I give you 100 and I give you 50. 100 divided by 2 is 50. So it means it follows that property. Angle at center is 2 times angle on the circumference. Understand? This must be 50. Okay, just something interesting. Okay, wait. I can extend it even further. Haven't finished it. Relax. I have a point D that exists somewhere on this half of the circle. Okay? Now, I tell you that the angle ADB is equals to 70 degrees. Is D on the circle, inside the circle, or outside the circle? And explain your answer. Okay, think about it. Then give me the answer. And I can do even one more. I have a point E that lies on this half of the circle. And I tell you that angle AEB is 20 degrees. Does E lie on the circle, outside the circle, or inside the circle? You go toilet? No. This is your ticket to go to the toilet. Okay, so for the rest, they are doing this for the very first time. Do you have an answer? Oh, I want the reason why also. Need to give the reason why. There is a reason why, I think. It's difficult to explain, so never mind. But I don't need reason, but you just need to know where they lie. Okay, we go on now. Just answer me. D and E, where are they? Okay, start on the back for fun. Which one? Okay, we start from D first. D is inside. Anyone different answer? For D. D should it be inside or outside? Inside. Okay, logically should be inside. How about E? E should be outside. Understand? You know the reason why? I mean, it's pretty obvious if you draw. If you draw it out, it should be pretty clear. Look at the way the angles are drawn. Outside is way skinnier. Understand? So this is just something interesting. I have more. No, I don't. Okay, I have actually more, but never mind. Okay, this is just for fun. Nice. Moving on into question 3. Okay, this question is not very difficult. Okay, but one of the parts is quite tough. I think it's part C. Part C is pretty tough. So let's slowly go through the whole question first. ON, CD, and then DAC. Let's start with ON first. Now, how do you find ON? Looking at this shape down here, do you agree that this looks very familiar to a theorem that we used just now? It looks like your chord theorem, which states that ON equals to OM. So, very good. How do you solve for OM? Trigo, definitely. Okay, so we're going to use Trigo to solve this. So A, okay, this one will go very fast, or faster, because it's simple. So the sine of 25 equals to OM over 5. OM equals to 5 sine 25. Now, because we are finding OM, we are not finding ON. So let's explain first. You need to say, by the chord theorem, ON equals to OM equals to 5 sine 25. Answer is 2.11. Okay. Now, one thing that I hope you realize, I never use exact answers. I never use exact answer. Sorry, I always use exact answer. I'm so sorry. I always use exact answer. Okay, the reason is because I hate decimals. Okay, for those that know me for a while already, you should know I say this all the time. I hate decimals. Okay, because one is a pain in the backside to write, and number two is very easy to premature out. Understand? So I will always leave my answers in exact form. Later, when we are doing the triple question that I want to do, same thing. You will see me use exact form non-stop. Understand? This is a habit you should start. I suggest that. Okay. Next one, B. For part B, we need to say that we need to find CD, right? Do you agree with me that CD is actually equals to AB? Because of your chord theorem, obviously. Okay, so let's prove that very quickly. Write down the solution. Cosine 25 equals to MB over OB. MB equals to 5 cosine 25. Let's explain that the lengths are equal first. So CD equals to AB because of the chord theorem. And therefore, CD equals to double of the MB length, which is 10 cosine 25, 9.06. It's here. What you can do? Can. Answer? No. But go try. Part C. Okay, part C is slightly more challenging. Okay, so if cannot do, it's still forgivable. Or if you're in sec 4, no, it's not forgivable. Okay, so how do you, oh, sorry, can see? Behind, okay? Can Okay, let's look at part C. Now, this one will take me a bit of time to explain, so please listen carefully. For part C, first thing we're going to do is definitely need to draw, because it's DAC, okay? Okay, so when we draw this, now, a question that I will ask is this. Do you know where does it cut on NO? Sorry? Ah, very good. That is the exact wrong thing I want someone to say. Okay, excellent. So, midpoint. How do you know that it is the midpoint? Because it looks like it. Correct? I knew it. Okay, so whenever you do questions like this, you need to remember, diagrams are not drawn to scale. You cannot say because it looks like it, therefore it is like that. Cannot. It doesn't work. It's okay. Okay, it's a good mistake to make. Understand? So, this is not the midpoint because we do not know. Okay? So this comes the very big problem. How do we solve this question? We don't have anything. We barely have any length. Correct? So what do you do? Anyone has an idea? Yeah, I give you a hint. You need to draw extra stuff. You need to add 2 lines. What are the 2 lines? And then it'll be very obvious. Sorry? You can't. Sorry? DO. DO. Yeah, correct. Very good. DO. I just want to scare you for fun. DO. One more. One more. Very good. Why? Explain. No. No. Okay, but this is correct. Anyone knows the reason why? How do you do the question? There is, I think, 4 more things you need to do. 3 to 4 more things. Yeah. Okay, look carefully at this thing that I've drawn here, especially all the lines I've added. Look at that 4 lines. Does it look familiar? What? Does it look familiar? Do you need me to highlight it for you? Yeah, correct. So this, and this. Does that look familiar? Is your angle at center equals 2 times angle at circumference property? Okay, so this means what? To find this angle here, you definitely need to find this. And can we find that? Cannot. Can we find? Yes, but need a bit of effort. Okay, so what is the effort that you need? Okay, go slower. First one, NOC. No, not NOC, sorry. ONC. What's the angle? 90. Okay, so far okay. What is NCO? What is NCO? Angle 25. Why? Because they are no, that's not the reason. Why is it 25? There's a reason why. Starts with C. Very good. Congruency. Because triangle ONC is congruent to OMB. Can you see why? Okay, we slowly if you cannot see it, slowly. NO is equals to OM. OC is equals to OB. Understand? And then this side you also can prove it's going to be equal in length. Because you have already justified just now that AB is equals to CD. Okay? So what is this angle NOC? 65. What is angle NOD? 65. Because why? ONC is congruent to OND. And therefore, DAC is 65. And that's the whole answer. Okay? That is the whole entire question. Okay, this one, the answer is going to be a bit long. Okay, so I'm not going to write, I'll type it out for you, and then I'll put in the answers for you. Okay, because it's really very long. So, yeah. But can understand the basics of how you get the answer? Okay, yeah. This one is just on a more challenging scale. Okay, we don't have a lot of time. We have about 10 official minutes left. Are you okay with me extending like 10 minutes? Because we started a bit late. Can I? If anyone needs to rush off or anything, you can go up. Okay, no problem. Okay, but don't everyone leave. Then I'll be sad. Okay, so the question I want is this. Okay, this is a beautiful question to go through. Okay, I don't have the time for you to try the question now. Okay, but what we can do is to straight away go through. So listen carefully, then we run through the whole entire question. Okay. Points X, Y, Z are on level ground. Very important, level ground. Why? This tells you that this whole shape here is two-dimensional. So you don't need to care about anything 3D, like anything go up or angle, don't know what, don't need care. All on a flat surface. Okay. X is 72 meters from Y on a bearing of 210. Remember what I say? Bearing questions are phrased in the same way of something, from something. They will always tell you the from. So what can you do? We know that it's from Y to X. Means that this whole entire thing here is 210. Understand? You can do the same thing for the other. Y is 120 from Z on a bearing of 260. So from Z, and you draw. This is 260. Now, we know that these are norths. This is a strategy that I recommend because we are going to be using a lot of north lines, a lot of north. You need to separate out the different norths. So what I would recommend is to label this as N1, N2, and whatever. Someone asked before, is it allowed to do that? Are you allowed to do that? Yes, there's nothing wrong with it. But a suggestion is this, you need to label in your diagram. That's the bare minimum. If you want to go a step further, you want to be professional when you're doing your work, you should write down in the question, let the north at Z be N2, that kind of thing. That is ultimately the best way. But if you really crunch for time in exam, don't bother. It's not important. But bare minimum must label. Because if you start N1, N2, N3 all over the place, no one is going to know what you're doing. Okay? So far, okay? Nice. Let's start the question. Calculate the angle XYZ. Now, pretty obvious. We definitely need to find what is N1YZ. Definitely. Then we take 210 minus that angle. Yeah? So how? Pretty simple. We find N2ZY by taking 360 minus 260. 180 minus the angle to give me N1YZ. 210 minus the angle. Okay? That's the whole solution. So far, can I? So I'm going to write the solution here. Please follow my presentation. Part A, same thing, I'll intentionally be doing a bit of weird stuff, and then I will tell you whether legal or not. Okay, but you can follow, of course. So angle N2ZY equals to 360 degrees minus 260 degrees, which is 100. Reason, angles at a point. Question. For bearing questions like this or any angle question like this, do you need to give reasons for your angles? Yes. The answer is yes. Definitely need. So please remember to write. Some schools, they say trigo don't need to write. Rubbish. Must write. Okay. Next, we're going to find N1YZ. N1YZ, which is 180 degrees minus 100. Oops. Which is 80, and the reason is because of interior angles, N1 parallel to N2. Question, is it allowed, is it necessary to write the two lines that are parallel? Okay, it's optional, to be very fair. Okay, it is optional. Okay, but I highly recommend. Understand? Yeah, it's like that one, have to ask. Okay. And the last one to complete the question is definitely XYZ equals to 210 minus 80. Answer 130. Got a reason? Nope, don't have. So one habit that you should have is this: always ask yourself, got a reason? Got a reason? Then you know you don't forget. Okay. This is the answer for part A. Part B. Sorry if you copy finish, yeah? Okay, part B. Area of the triangle. Okay, this one's straightforward. Half times xy times yz. Sine the angle. Very, very easy. Everyone should be able to see this. Any problems with this? No. Okay, let's write it down. Let's go. Area is equals to half 72, 120, sine 130, answer 3310 meters square. Okay. Too fast? Okay. Part C. Find the distance xz. Should be pretty obvious as well. We have xy, we have yz, we have the angle in between. This is cosine rule. Okay, this is cosine rule. So let's label cosine rule by cosine rule. Okay, this one kiasu, but I'll just write for fun. By cosine rule. And let's work out the whole thing. Xz equals to the square root of 72 square plus 120 square minus 272, 120 cosine 130. And this value answer 175 meters, 3SF. A suggestion is this. This is just a tiny thing, very, very minor thing. Some people, instead of writing like that, they will write first xz square equals to the whole thing, then you square root. Okay, if it's me, I would save the trouble by doing that. Why? Because if you take the square root, you need to remember to reject your minus answer. You get what I mean? Okay, so there's an additional step you need to take. If you don't want to do that, you just start from here. Because it's automatically, you're going to take the positive answer. Okay, so this is just to save life. Part C done. Part D, donkey. Find the bearing. Bearing of Z from X. From X. So means you draw a north. Okay, N3. My north not straight. Okay, but never mind. N3, and this is your angle. Now I hope it's pretty obvious. What do we need to do? We need to find what is this N3XY and also this inside angle. Let's do the inside one first. That's the most obvious. No, that's not the most obvious. The one on the outside is more obvious. We take interior between the two norths. Okay? So that one's straightforward. Done. Let's look at the one inside the triangle. You have three sides, one angle. You can use cosine rule. You can use sine rule. Anything works. For educational purposes, let's use sine rule just to practice. Okay, sine rule. So this is part donkey. By sine rule, okay, the sine of angle YXZ divide by 120 equals to the sine of 130 degrees over, okay, wait, pause, XZ, right? You're going to use the exact side. But you see, your exact answer A is it's a final answer there. So can you use 175? Obviously not. So what do we use? The 5 significant version of the answer, or if you're weird like me, use that, the whole square root. Okay, but I'm not going to write this square root non-stop. So if you know me for a while, I will do this. Equals to the happy face. What? Correct, I do this all the time, right? Yeah, it's true. Equals to the happy face. I'm serious. Later. Later. We don't spoil the fun. I will tell you why. I'll tell you later. Okay, slowly first. Okay, so equals to the happy face. So this is equals to the blue color happy face. And then we'll start solving. Okay, so angle YXZ equals to 120 sine, sine inverse, sorry, missed the sine inverse. 120 sine 130 divide by the blue color happy face. Close the bracket. Hey, wait, is this the final answer for the question? No. So should we calculate the value? You can, but I'm not going to. Because I love this exact form of the answer. It's up to you. Okay. Now let's work out the other friend first. The one on the outside. N3. So remember, it's 360 minus 210. 180 minus the answer. Okay. We're going to save this and do everything in a single step. Angle N3XY equals to 180 minus 360 degrees minus 210, which is 30. So this is a nice answer, so we can write it out. And therefore, bearing is equals to sine inverse 120 sine 130 divided by the blue happy face plus 30. Final answer, 61.6 degrees. Is this correct? No. What are we missing? 0. Very good. 0. Okay. Very good. Okay, I'll answer the $1 million question in a while. Whether is that blue color happy face allowed? Later. I'll answer in a while. Okay. It's a very, very interesting answer. And part E, the very last part. Okay, let's quickly go through and we're almost done. A kite was seen flying 10 meters vertically above a point Y. Okay, so let's draw the kite. You have a kite at the top there. Oh, you laugh. Correct what? Kite what? Okay. So you have a kite there. Find the greatest keyword greatest angle of elevation of the kite observed by a person walking along XZ. Greatest means perpendicular distance. Ooh. So let's identify where this is going to be. So you have a guy walking somewhere, and then we want the perpendicular distance. So let's mark it out. I'm going to erase my angle there. Agreeable? And then to the kite. And then down. Now, I know it looks like I'm tracing the north, but I'm not. Just imagine the north is on the paper. This became a three-dimensional diagram. Okay, look at it carefully. Now, how do you calculate this? So there are a few different steps that you need to take. Remember what I always say. Shortest distance is always paired together with what kind of question? Area. Correct? You notice there's an area in part B? That's why we use the area. Okay. So, because it's me, this is disgusting. Can we use 3310? No. So we use the exact form. So let's simplify this, and I have it 4,320 sine 130. Okay, if you use the 5SF, can go ahead, no problem, up to you. Okay, but for me, I just hate writing decimals so many times. So it's up to you. Traumatized by it. So part E, area, equals to 4,320 sine 130 equals, okay, this one is going to be quite cute, so follow up, equals to half times XZ, right? Can we use XZ? Cannot. So we use the happy face. Okay, wrong color. Times the length. Let's call it A. And let's make A the subject. So A equals to 2 copies of 4,320 sine 130 degrees divided by the blue happy face. Why do you laugh? It's true. I'm not doing anything wrong. This is math. I'm trying to make it fun. Okay, and we're almost done. Almost done. Now we need to find the angle of elevation. So what ratio do we use? Tangent, obviously. Okay, so we take tangent. Tangent of alpha. Now what is alpha? Alpha is this angle here. Tangent of alpha is equals to your height of your kite is 10 divided by your A, which is the whole entire computation there. Take the inverse, get the answer. Alpha equals to 14.8 degrees, 1 dp. And that's the whole answer for the question. Okay, to answer the $1 million question, are you allowed to use the happy face in exams? What do you think? Yes or no? The answer will surprise you. Huh? Controversial? No, it's not. It's not. It's not controversial. This one not controversial. This one got a definite answer. Yes or no? Yes. You can. There is nothing wrong. But there's a caveat to it. Okay, there's a tiny little thing against it. Okay, listen up. The only reason I'm using happy face is because I don't want to make life boring. If you want to use X and Y, it looks a bit boring, in my personal opinion. So that's why I put happy face. Okay, for me, the different shapes I use is always happy face, sad face, happy face with a thumb. That's what I do. That's what I do. To make things funny, okay? Or sometimes I'll draw a goat. Okay, to represent different things, okay? Because like if I keep on using XY, it's a bit dry, okay? So that's what I do. But in exams, you're not trying to entertain people. So no, in exams, just change it to X and Y. There's nothing wrong with it. But there's a tiny thing here, tiny thing. Okay, if you make mistakes, you will lose all your metal mark. Okay, this is the only danger of using this. Okay, because metal marks are checked by your answer. So if there's no answer, everything will go. Understand? So that is the only tiny little thing. You decide yourself. You want to juggle with fire your own problem. Okay, and we're done. Every question is done. Okay, thank you for staying with me for the last part. Okay, for this whole entire question. Okay, last thing before we end, I got just 3 more slides to go through. Sorry for those that have seen this before. Okay, but hope you benefited today. Hope you learned something. Hope you enjoyed it. Okay, I try to make it as fun as I can now. Okay, this is my 4th last session. Clap. Okay, thank you. Okay, joking. Okay, so now if you like my teaching style, okay, if you like the way that I teach, I do have signups coming out soon. Okay, I do hope to work with you lah, so I can help you with your O levels. I can promise you an A if you work hard. If you work hard, have you been working hard? Sure or not? No belief. Okay, so if you have been working hard, okay, yeah, should be fine. Okay, now the reasons why we start lessons so early is because I want to finish syllabus by 10. That's the reason why. Okay, then it's revision all the way. That's my reason. Okay, now last thing before you go, okay, can you help me fill out a small little survey? You fill before, don't you? What? Wait. Okay, so help me fill out this tiny survey, okay, to evaluate my teaching and also let us know how can we make the sessions in the future better. Okay, if not, thank you very much. Hope you enjoy yourself. Okay, all the best for your exams. Sorry. There's no what? Oh, what? Mock exam coming soon. I'll let you know. Yeah.